this presentation will be in English, so I hope you don't mind. Forgot to say that. Alright. Okay, today we'll get a little bit of taste what React Native is. And it's kind of faster than light crash course. I will try to half an hour to explain all the internals and the basic structure of React Native, also how you use it for regular usage, and how you can even extend native models to be available inside React Native ecosystem. So yeah, I didn't forget to upload my screen. So my name is Vladimir Novick. I'm a web architect and consultant at Code Value. On a daily basis, I do web, mobile, VR, AR, MR, IoT, lots of things. Today I have a strange slide. Sorry for the mistake, but anyway, I have some assumptions about your knowledge. I assume you're familiar with ECMAScript 2.15. If familiar at least a little bit with React.js, and you're eager to learn new things. So, what is React Native? Let's take a look what is said in official docs. Basically, React Native gives you an ability to build mobile apps with JavaScript. So we basically talking about hybrid app. No. We're not talking about hybrid apps. Talking about actual mobile app. In recent years, we had several solutions like PhoneGap, Cordova, Ionic, and stuff like that that gave us ability to write in JavaScript, HTML, and CSS, and in the end, having a seemingly mobile app experience. But under the hood, this mobile app was running inside a web view, so the actual experience you got was not compared to any native ones. So React Native gives you the ability to write an actual mobile app. The motivation of creating React Native was reuse between code reuse between mobile platforms. Most of the code is reused. Some of the code is not reused because they have different mobile APIs on Android and iOS. We have smaller development teams. Consider you want to develop a mobile app, so you need basically an iOS developer and Android developer if you want to target both platforms. In case of React Native, you basically need a front-end developer or web developer who can use his React knowledge to create actual mobile apps. We will stick to the same ecosystem we use in web in React. We will use Redux, we'll use Mobix, and all these cool tools we use in React. The programming style will be declarative and more functional, like in regular web React programming. And the most amazing thing, you will style with CSS. Well, it's not really like CSS. It's not really CSS, but it looks like CSS. So you basically will style with Flexbox grid, and you will use all those properties you are regular to use in web. So React Native architecture looks like the following. I have several threads running on our mobile device. I have main thread, which is basically the native thread of our mobile. It's used for layout, it's used for measuring, it's used for drawing. Then we have JavaScript event loop, JS thread, which is an event loop that executes your JavaScript code and sends updates based on React diffing mechanism. Basically, it happens before every frame renders, meaning on iOS 60 FPS, which is something like 16 point something milliseconds. You have each update happens. And then you have the shadow thread. This thread calculates layout and layout changes and sends it back to the main thread to do the whole drawing thing. Also, you have several native models like you have videos, you have camera, you have image pickers of sorts. You have lots of native models. Each one of these models will run on its separate thread. So basically, we have multi-threading here, opposing to the one thread happening for hybrid app. So if we would draw a diagram like this, how the architecture looks, we have JavaScript event loop, we have a bridge, our shadow thread, and we have our Android or iOS native code main thread that executes all the drawing and updates. The execution flow happens in this order. When you start, when your React Native application starts, the main thread starts and fetches all JavaScript bundle. That basically means that you can fetch this bundle over the network. Later we'll see how we can benefit from it to deploy our apps more fast and have an amazing developer experience because of it. So we fetch all our JavaScript bundle, and then our JavaScript starts inside the JavaScript thread, separate thread. The whole your code you wrote in React Native, the whole JavaScript code happens on JS thread until React renders. When React renders, basically React Native executes diffing mechanism, which in turn sends its updates, batch updates to shadow thread to do the calculation of layout, of how things are laid on the screen, drawings, specific calculations to the platform you develop on. And then, when all these calculations are done on a separate thread, everything will be sent to main thread back, and your native code will execute all the logic. And as I mentioned here, native models will run on separate threads. Maybe they will have some calls from JavaScript thread if you specifically mention some. If you specifically call API of native models, but basically they're happening on a separate thread. So how would we get started with React Native? Until a year and a half ago, we had one option. We had to install a bunch of dependencies for Android, for iOS, and basically we used one tool. We did npm install global React Native CLI, and then we had a CLI to generate our application. Now we have another option. We have Create React Native App. Basically, it's inspired by Create React App. It's a community tool to create a React application for web using best practices in industry. Create React Native App sits on top of Exponent, which is a framework that sits on top of React Native. We'll cover it in a bit. And it gives you much more amazing experience than React Native gives us in terms of development and debugging and such. I don't know why I have double slides. Okay. So with the React Native CLI, basically what we have is we create our app. Our React Native app is created and it's installed inside a simulator. So obviously we need to install all Android dependencies if we want Android simulator. If we want iOS, we need to install Xcode. We need to install several other dependencies.
I have a question. In Android, you have to install the handling statement?
With the React Native CLI, you do, because you want a virtual device, you need all the Android environment and such. And then when you run React Native with React Native run iOS or React Native run Android, our JS code is executed. Basically, it goes through the transpilation, through the mechanism called JS packager. It's sort of Webpack-ish, so it transpiles all your code into the code that React natives can consume. In terms of syntax, we have here ECMAScript 2.15, and we have selected features from ECMAScript 2.16, like async await, like object rest spread, and other goodies. So for React Native CLI, we need to, as I said before, we need to install dependencies. We need to install, for iOS, we need to install, basically for everyone, we need to install Node. But for iOS, we need to install Watchman, and we need to install Xcode. For Android, we need to install Node, Android Studio, JDK 8, and really advisable to use Genymotion, which is much better emulator for Android devices. And then we run React Native init my project, and you have your React Native project. And you can later click on official docs and check it. Returning to the great React Native app and the whole Expo framework I told you about. So what is actually Expo? So it's a framework built on top of React Native. It has additional native APIs. It has a desktop XDE, which stands for Exponent Development Environment. And it has mobile client, which is really awesome. Like you have application on your phone, and then from desktop XD, you can just click a button, run on my phone, and then you see your application you're developing on your phone. Of course, when your phone is connected to a computer. Also, you can share these things so everyone on the same network can check this application and much more. Also, Exponent has Expo Snug playground. It was previously called Sketch, but I think they had legal issues with SketchUp, so they renamed it to Snag. It's like a JS Fiddle for React Native. Like you have a whole environment inside the browser, you can develop native apps, even you have drag and drop of your components based in actual code. So you can browse the list of your components, you can just drop your React Native components, and you can see application inside your web browser, and later on you can transfer this code to the actual native app. So Expo XDE gives you an ability to share your project on Expo Client app, as I said. It gives you an ability to develop on device with additional setup. Without additional setup, it manages React Native packager processes, which without Expo can be a bit tedious because React Native packager sometimes doesn't clear cache, and you can have the older version of your application running simultaneously with your newer version, and you can get conflicts. So in terms of managing processes of React Native packager is really awesome too. You have additional logging, like I will show you in a bit, and then you have publishing. You can connect to Expo XD with your Exponent account, and you can publish your app through the Exponent. Meaning your app will be live for users. It will be live through the Exponent ecosystem. Means you can use push notifications from Exponent. You can use several other things. Some of them cost money. Some of them don't cost money. So you need to decide. So when you create a project with Exponent or with great React Native app, the lifecycle will look something like that. You can from XD Just click a button, new project, and it will create new exponent project. Or more advisable, you can use create React Native app. And then you develop a project locally with the XD. You can publish it to some URL to share on your device, as I said, a mobile client, or you can share with people and or stuff like that. And then in your create React Native app, you can always detach from create React Native app. Meaning, you want to develop on your own, you want native models, you want to extend things, you don't want exponent, you want the initial bootstrap, and you want to use for initial application, which will heavily use JavaScript and mostly won't use native models. You want to develop in exponent to get the speed, to get things done, maybe to get your MVP live. But then you want to detach from exponent and say, okay, I want this awesome native module to include it in your app, so I will include it, but I will detach from exponent. You won't get the benefits of exponent development environment. You will still have all the capabilities of React Native development experience, which is great on its own. But you have this flexibility to choose what you want. So for create React Native app, you basically install your React Native app, then you just create it. This application can be viewed in Expo XD, it can be injected to vanilla React Native, as I said, and can be injected to React Native plus Expo. Meaning you want your native models, but you still want some of things from Exponent. You want to use some of SDKs they gave you. You want to use, for example, push notification. So you basically can inject your React Native plus Expo. You will get that. So as you can see, I have the flexibility of using React Native CLI, flexibility of using Exponent or using Create React Native App. That's something that wasn't out there a year and a half ago, and lots of people struggled with the initial setup of the Android and Android Studio and all dependencies, especially on Windows. Setting React Native on Windows was really a pain back then. Now it's much more pleasant experience. How do you run your app? For Create React Native app and Exponent, you just run it from Exponent XD. And for vanilla React Native, you run it with Run iOS. Let's take a look what you get when you create your app. This app was created with Create React Native app. You get .expo folder with some of Exponent dependencies, node models, bubble file, and App.js, App.js. Basically, your application sits inside App.js. Then you can, as I said, always eject this app to get the regular React Native project. In regular React Native project, you will get index Android and index iOS files, and in this case we have App.js and App.js. We'll take a look at the code in a minute, but basically React Native knows that it runs on Android, so it will include index.android. Same you can use for specific models. You want to load some model only if it's on Android, so you just name it .android.js and it will load it on Android. And with the React Native CLI, you will get all these things. This folder structure, app, assets, components, config, lib, screen, services, and index.js. It's not something you will get out of the box. It's more like to show you how the regular application should be, folder structure should look like. Like you have your assets, images, SVGs, icons, stuff like that sitting inside assets, components, obviously inside components. In every application you have several screens, so screens will sit under screens, services will have some external logic, like maybe API service to call some for example, Firebase authentication to authenticate your app or stuff like that. And lib, it also can be called as utils, and inside config you basically put constants, routes, stuff like that. So let's take a look at the code. Who's not familiar, this is the screenshot from Westworld, and they use React for it.
Can I ask a question before we start with the actual code?
Yeah.
First, two questions actually. First, is it officially supported by Google and Apple?
Yeah.
And the second is actually two questions. Do you have a benchmark of app performance and development effort?
I don't have it here in this presentation, but for sure you can get all the benchmarks of performance on the official docs itself. And in terms of performance, as I mentioned, the loop between JavaScript event loop and the bridge and the main thread, you can understand that then bumping back and forth can be really performant, right? So for that, we need to prepare and optimize things accordingly. For example, in React, you have a lifecycle method called should_component_update. When you check your previous props and next props to understand if you need to re-render or you don't need to re-render. You need to think in the way that each re-render will get to the bridge and get to the main thread. So you need to make your re-renders as little as possible.
I understand this is not real time, and you need to take into consideration the way that I'm asking about the comparison or benchmark with the native development platforms of iOS and Android. This is the benchmark that I'm referring to.
For heavy calculations inside JavaScript thread, the React Native will be less performant for sure. So if you write it correctly, basically you will get almost, if not the same performance as for real native application. Okay, so let's take a look at the code. We have index iOS and index Android. I showed you before. Basically, inside it we have just a simple import of app registry from React Native, app which you saw in App.js, and we have this kind of bootstrapping code, app register component, and function which returns app. This will be in every React Native application. It's the entry point, and basically app register tells the bridge and tells native model that I have this chunk of code, JavaScript code, please transpile it and please work with it. So basically it's the entry point. And this is the app. So if you've developed with React, you can see the similarity. You have import React and have default class app, which extends React component. And instead of div and regular HTML tags, you have view, which is, you can think of view as a div. It's basically a container. And you have a style prop, and you have some text used for rendering text on the screen. As you can see here, style has styles.container, which is basically looks like CSS and JS, right? It's flexible, background color, and line items. It looks familiar, right? It's not the XML-ish syntax that is used on Android, for example. That's more web development syntax, web developer syntax, right? So with all the awesomeness of writing React and getting the native app, you have really awesome dev tools like these dev tools you will have for Exponent of React Native app, and these ones you will have for regular React Native CLI application. You can see here you can debug JS remotely, you can have live reload, hot reload, an inspector, performance monitor, and really awesome things. You can debug in Chrome, your mobile app. You can log things out, you can put breakpoints, you can just debug your code as normal web code, but it's the native app. You have this awesome project called Red DevTools. So it basically lets you, like in the web, you're inspecting your HTML structure. The same here, you can inspect your application structure. Like we have app container and view. RCT view is the native one. The native view, the native model that is extended into the JavaScript view you use in React Native. And all these things, you have even the box model here and styles, and makes mobile development much easier and awesome experience. Yeah, let's read the manual. This is the official docs. Have lots of components. Have the basic ones: views, text, image, text input. Have several things for user interface. Have lists. From regular mobile apps, you know that you have like regular list and lists with sections. So have flat lists and section lists. You have things specific for iOS and things specific for Android, and lots of others. Now I need to somehow exit. I cannot do next because it's an iframe. Second. Here. Sorry for that. Yeah. Was unexpected. Yeah, so I told about the So I told you about styling in CSS. So you have a thing called Yoga. It's not the actual Yoga. It's a cross-platform layout engine used in React Native. It uses Flexbox and all the common properties you regular from CSS. And if we'll take a brief look how it looks like, so you have width and margins, paddings, background colors, and align self, and everything that looks familiar from web development. With some things different, like you don't have pixels, you have like border width is like one unit or something. It's not like pixels. So it's CSS in JavaScript, almost CSS in JavaScript. So you can use here variables and stuff like that. And Nick today will talk about all the benefits of CSS and JS. So we have like this styles object, and we have previously you've seen that we have Stylesheet create. That basically almost the same with one difference. Stylesheet.create gives you basically create the style sheet and reference it by ID, and you don't need to create each object on each render, so it's much more performant. And also we have navigation. So our navigation, previously we had navigator component in React Native. It was deprecated like a week ago, I think, when 0.45 version came out. It was deprecated, and now we have official support for React Navigation.org, which is a community package, and it looks like this. you have Stack Navigator and you define your routes. It's not like a browser route, it's a little bit different logic, but you can understand you have home screen and you have chart screen. So you say home, screen, home, which is a component. And chart screen, which is also a component that's important. And then you just return your navigator. In React Native navigation, I have three navigators. You have Stack Navigator, Tab Navigator, and Drawer Navigator. Stack basically means if you want something to do back and forth, like you have a back button with a header, do Stack Navigator. If you want to switch between the tabs, even if you don't display tabs, but switching without back functionality is Tab Navigator. And Drawer, it's the menu coming from the side, so it's the drawer. All the navigation options can be passed inside static prop inside your component itself with navigation options. Like in this case, I pass title. And then in the header, I will see home screen. Then inside render method, in order to navigate, I just use this props navigation navigate chart with some parameters I can reuse on the next screen. So consider this screen structure. Like you have kind of generic application. You have a welcome screen, and then you have the main screen with maybe authentication or main flow stuff, and then you have two separate screens, and you have like settings button above. If you click it, you get the settings screen, and you can click back and return to your regular screen. So in this case, Tab Navigator without tabs will be the welcome and main. Tab Navigator will be used for screen 1, screen 2 with the actual tabs. And the Stack Navigator will be used for settings because we want the back functionality. That's for navigation, briefly. I told it's faster than light crash course, right? So animations in React Native have two systems of animation. We have layout animation and we have animated. Layout animation is with layout animation, you define your animation, and it's relevant to all your components next to the render cycle. Like I say, fade in inside animation, and all my components, all my child components will fade in. I cannot target specific component with layout animation, but it's really easy to use, and it's almost one line of code. It's, as said here, apply to all styles properties of components, and you don't need specific values, heights, width, nothing. You just specify fade, zoom in, zoom out, basic stuff. Cons, it's obviously less configurable, and it animates everything on next render, and if you set state during animation, which affects animation, it won't actually affect animation. Layout animation happens on main thread. When your component is created and you say in component will mount, you say layout animation configure next. That's basically the API to use it. The whole animation description is sent to the main thread, and you cannot pause it. It's there. It's outside of JavaScript event loop. It's really performant. You get really native animations, but you cannot stop them in the middle. With animated is really extremely configurable. You can configure everything. You can interpolate things. You can say when I scroll from point 1 to point 100, if the range is between, y is between 0 and 100, make my color change from black to white, and you get all the transpilation based on the easing curves that exist inside React Native. Basically all the known easing curves. The cons, by default, it runs on JavaScript event loop. It uses request animation frame by default. 3 versions ago, it was updated to include, you can pass configuration called use native driver. And if you pass it in your animation, the whole animation stack is transferred to the main thread, and you get the same performance as layout animated. But with the same cons, you can't stop in the middle of animation. If set state takes time, animations can stutter in case we use the request animation frame. So the basic examples, like this example is for layout animation, and animated is like you see have several. You have zoom in and like spring kind of thing, and when it's fades out, you have fade out animation. So that's for animation briefly. Networking. We have fetch API. So the whole fetch API thing, and also we have a polyfill of Stylesheet requests, so you can use even libraries like Expo and stuff like that. But it's really advised to use fetch API because it's a modern standard, so use it according to MDN docs. And you have WebSockets, so you can use WebSockets like you use it in web. Platform APIs. Yeah, it's a long list. It's unreadable, I know. The reason it's so big and unreadable to show you that there are a whole lot of platform API that's supported in React Native. You have geolocation, you have pen responder, which basically all gestures you want on the screen. You have like camera roll and image pickers and vibration and lots of stuff. Of course, it's much less than the actual device gives you, but for that you can extend your models inside something to give to access another native models. Expo SDK also will give you this lot of native SDK. So if you use Exponent, you also have gyroscope, and you have Google login and Facebook login, and you have like permissions and accelerometer and pedometer even, I think. Yeah, we have pedometer. So you can measure steps, and you have lots of things, video and SVG and stuff like that. But eventually, we will want to deal with native models. So you will have you have all the NPM ecosystem. So obviously, you will want to install. When you want some native model, some module, you search for NPM package, and then you see that this NPM package contains native modules. So what do? You install it, and you run React Native link. That's it. The React Native link does everything for you. It adds settings inside Gradle file for Android, and adds project as a dependency inside Xcode for iOS, and does a bunch of things. Usually, if a package requires more than that, it will be listed in package README, so it will be pretty descriptive. And you can write your own native models. So how do we do that? Briefly, in Objective-C. You create two files. You create my native module header file, and you import React RCT bridge module header, and you declare interface, which basically extends the RCT bridge module. And then you have your native model. You need to implement this interface you've created. And then you have this RCT export model. It tells React Native that your native model will be available with this name. And then you export method with called log info, which will get a string, text, and then you will log your text. I know it looks familiar, maybe it's Objective-C, but you see how little code you need to extend your native model inside the JavaScript ecosystem. And then you can use it like this. You import native models from React Native, and then my logger has native models.exported model name, login for test message, and that's it. That's basically the connection. For Objective-C, it's easy. For Java, it's I didn't even include the code because it's much more. Basically, you have two steps. The first one, you create a class that extends React context-based Java model. Then you need to expose your method to JavaScript using this annotation, React method. Everything that will be annotated with the React method will be exposed to JavaScript. And then you have step 2. You create a package for model and register. Basically what it means, you create a class that implements React package and override React native models method. All the docs how to do this and the whole code, it's long because it's with a bunch of imports. It's here. So this is for your native models. And for deployment, the last one, you can build your app, you can deploy it in regular ways, like you run your build, you have a bundle, you build your project in Xcode, and you deploy it. You sign certificate and deploy it, like regular iOS application deployment. Or you can use these two cool tools, one of them basically. Code Push, Microsoft Code Push, and App. Basically what it gives you an ability to register to Code Push and then to say, okay, I want to deploy to Code Push. Your JavaScript bundle will be deployed to Code Push servers and will be served as a bundle to the actual application. Meaning you don't need to the whole process of signing you up through the App Store, which takes lots of couple of weeks at least. You don't need that. You just deploy through Code Push. And if you don't have native models, if you have only JavaScript code changed, then it will be deployed automatically to your application on the fly. Which is really cool, and also really cool that Apple allows that. The same for Android. App is basically the same thing, the same idea. It's the different service, so you can use either of them. And that's basically it. That's the whole React Native FTL course ish thing. I hope it was descriptive enough. I really advise to look in the docs, especially now after all 0.45 version was released. They really extended their docs, including several guides, and also they included the exponent ecosystem, how to use that, even in the official docs. So that's it for React Native. React VR after the break.
Yeah, I think we can have 10 minutes break, and then we're going to see some cool stuff, I guess, with React and VR.
Yeah.
I mean, the whole purpose of this session was just to prepare the ground for the VR stuff, right?
I assume you didn't like the...
No, it was great. I'm just not really doing React in my day-to-day, so I'm
Don't worry, you'll see cool stuff in React VR.
Yeah, maybe you'll convert me in the next session. So, as הפסקה. אתה גם יודע לדבר עברית?
הפסקה.
הפסקה. סתם. נעשה הפסקה של 10 דקות, יש כאן בחור